Yeah.
That was very good. Okay, let me do an introduction. Lek is going to be talking about habitat conservation, the success and succession of native grasslands. Lek has a master's in mechanical science from the Yale School of Forestry. He's the founder of the Golden Hour Restoration Institute, a gateway for learning about the conservation and restoration of nature. It's based on the principle of education through action, and he currently serves as their executive director. He's a co-author of the Annotated Checklist of the Flora of the East Bay, which is a CNPS Jepson Herbarium publication. He serves on the California Native Plant Society Conservation Committee, has served as a conference session chair for restoration 4 times, serves on the steering committee for the Conservation Lands Network. He's authored several scientific studies of rare and endangered plants on San Bruno Mountain for the county. He's also a personal friend who's taught me some wonderful lessons of how to be an academic botanist, and I'm very appreciative of what he's taught me. And absolutely no one can equal him in bounding over the steep hillsides of San Bruno Mountain like an antelope. And it seems for him, the steeper the better. And it gets so steep that he has to hold on to poison oak to keep his balance, but he keeps on going. He's a great guy. He now lives in Montana with his family, and I'm quite proud to say I'm a friend of his. Lek, you've got it.
Thank you very much, David. I appreciate that introduction. Can everyone hear me okay? David, is the audio okay? Thumbs up. All right. Beautiful. Well, I am absolutely honored to be here today and speaking on behalf of one of my favorite topics, which is grasslands, and in particular, habitat restoration around grasslands. So I'm a little bit more of a neo-endemic in the San Bruno Mountain world. I have spent now probably about 10 years bounding up and down the mountain, which is quite a few years less than some of the esteemed colleagues and faculty here. But a lot of what I have done under the tutelage of Dr. Stu Weiss, who will speak later. I'm very appreciative for all he's done, as well as learning from David and Doug, and then of course the county parks department, Ramona, and then now Hannah, who has taken over her role. So I want to take a little time to talk about success and succession of native grasslands, and really wanted to kind of shift gears maybe a little bit, talk a little bit about the academics, and then take those academics and talk about how we're trying to institute changes in stewardship to make use of those scientific studies. So if you will, applied ecology. Here's a recent photo of San Bruno Mountain. I'm sure everybody has a very similar photo. This is actually one I got to shoot on an airplane coming in to town. So it's actually taken within the last 4 months. And every time I look at this photo, I think one message that comes home to me is that San Bruno Mountain, in essence, looks to be mainly an herbaceous community. You don't see too many trees, you don't see a lot of shrubs on there and such. And that's kind of how I believe there's this mentality of how it's been stuck in people's minds as a very much a grassland dominated system. I want to talk to you a little bit about that today, and maybe open up your eyes next time you're out there and think about some of these concepts. So my biggest introduction to San Bruno Mountain and most in depth was doing a 30-year assessment of the habitat management HCP, Habitat Conservation Plan. So I did this through Creekside Center for Earth Observation, otherwise known as Creekside Science. This was with Stu Weiss, Crystal Nieder, and Jimmy Quinnell. We spent a whole lot of time out on the mountain. We spent a whole lot of time going through documents, learning from a lot of folks. And this was kind of a remarkable point in the conservation trajectory, especially domestically, where suddenly we were able to look at habitats as a whole rather than simply individual species. So this was the first ever habitat conservation plan I know a few other speakers will talk about this at length, but again, our role in this was to take a look at that and say, hey, it's been 30 years, how do we do? And so what I'm going to present to you today is just a tiny little piece of that, which particularly looks at grasslands. So grasslands, a lot of the time we spent out there, we started to notice more and more what we thought were intact, large-scale grasslands were in fact a lot smaller than we expected, and they were a lot more fragmented than we expected. And we started to piece together this idea that maybe grasslands are disappearing. So one way we wanted to try and prove that hypothesis and think about it in a couple of different ways. And one is something as simple as using a habitat proxy. So we looked at the GIS occurrences for Mission Blue. So in this case, you can see all these little blue dots. This is many, many years of data, I believe 25 years of data. And this shows where the Mission Blue butterfly has been observed. Mission Blues will fly into scrub a little bit, manzanita scrub, but they're not very good flyers. And so they tend to try and stick to very good areas. So this, just looking at the occurrence of where we're finding Mission Blue, started to become a hint of where grasslands are. So this is using real data, using it to approximate what kind of vegetation communities we're seeing there. And on this right here, we have a photo of typical lupin-dominated habitat. This is primo Mission Blue habitat, if you will. The next thing we did is we had this fantastic set of maps. So if you look at this top one here, David, I can see you on my screen. Give me a thumbs up. Can you see when I move my cursor? No? Okay. So I won't waste time moving my cursor then. This top map, you're going to find, this was a 1932 Vegetation Survey. And you can see these are these wonderful hand-drawn maps on USGS where they're showing the polygons. Basically anything in that map that is not, that doesn't have a stippled pattern or a shaded pattern, that was classified as grassland. The diagram lower, or the map on the lower end, it was the same study redone in 1980. This is by TRA. So this was 50 years later, let's call it. And what you'll notice is very quickly there is a huge decline in that clear area, and there's an immense growth of that scrubby stippled area. So that was another hint that things are going on in the system. Here's another qualitative measure we looked into. So when the 1982 Habitat Conservation Plan was initiated, you can see that top photo that has the 1982 on it. And this is up one of the most prominent ridges. This is between Owl Buckeye Canyons, and you can see predominantly grassland, and then you go through those different years. So we had a photo from '06, and then we took one in '14, and qualitatively, it was fairly easy to see that grasslands are declining, even in our high quality areas. So we actually took these historic images and calculated some grasslands. Some of this was already done for previous reports. So in 32, we had about 1,960 acres. In 81, when the HCP was initiated, it was estimated or mapped, grasslands were mapped at 1,419 acres. And then in 2002, which was some of the most recent aerial data that we looked at, it declined further down to 1,297. So basically over that 70-year period from 32 to 02, we estimate that about 663 acres of grassland were lost, so about a third of the grassland, an average loss of about 9.5 acres a year. Something was happening here, and it was happening pretty quickly. So it asks, you know, then forced us to ask the question, can you have a grassland? Is a grassland still without mostly grass? And the answer to that is we had to look into the vegetation manual, figure out how we felt comfortable defining grassland, because that's what is at the essence of this in the end is what kind of metrics are we using to define what a grassland is. This photo, as you can see, this is a east-facing slope on San Bruno. So from here, you can basically see the South San Francisco ferry terminal. This has become quite filled with vegetation that one would likely not describe as grassland. And so we really started to take a formal look at how we classify grasslands and really think about the analysis. So just going into Manual of California Vegetation, I'm sure many of you are familiar with it. If some of you are not, it's a really nice formalized way of defining the vegetation groupings that you're seeing on a landscape. So trees versus woody shrubs versus non-woody shrubs, right? Those are the first obvious breaks there. And then a grassland really becomes defined as an area where the vegetation cover is less than 20%. Where total vegetation cover is greater than 20%. So what they're saying there is we don't want just rock outcroppings that are mostly bare and have a few grasses. That's not what we consider grassland. And the layer of shrubs and subshrubs and trees, say that 3 times quick, shrubs, subshrubs, and trees are less than 10% cover. So that's really what we're looking at is that 10% cover as that threshold for defining something as grassland versus scrub. So I want to show you a little bit of, and hopefully without my cursor, you can make sense of this. This is a figure from the report. This is the extent of the grasslands in 2004 that were mapped. And so basically what you see here is predominantly a map that's kind of peachy in tone, right? Or maybe it's orangey on your map. That is all considered grassland vegetation according to the most recent vegetation surveys. Instead, what we did is we went back into some of those areas and traced some purple polygons. So those should show up for you. They have a number 1, 2, and 3 by them. Those are areas where there is much greater than 10% cover of shrubs. And as we continued to do this across the mountain, we found that actually the percentage of grasslands on the mountain, the percentage of area classified as grassland on the mountain was dramatically overestimated. We're talking about a 20 to 30% in some cases overestimation of grassland. So when you add in, we lost 600 over that 70-year period, and then you say, uh-oh, we may actually be 20 to 30% overestimating, then you see a much greater decline in these grasslands. So what we were seeing was disappearing grasslands. This is Stu and I out in the field. We spent quite a bit of time really getting to know the mountain, hiking it. He taught me a lot about different areas that he had visited and seen before. But even as you see here, this is an area where you can see scrub encroachment in the center of this photo. And it is quickly succeeding over to scrub. So with the disappearing grasslands, one thing we noted is there's actually a disappearing quality in grasslands. So it's one thing to be mapped as a grassland. It's a second more important metric is to really think about, well, what makes that grassland important for habitat, for vegetation, for diversity, for resilience, whatever it may be. So looking at habitat quality, one plant that's interesting that we have a whole lot of data on, again, using a proxy for it, or what we call an indicator species, is Viola Paduculeda. So this is our viola that serves as a host plant for the silver spot calippe butterfly. This is the yellowish plant that you'll see with the dark heart in the photo. This tends to get outcompeted in tall grasslands, overly fertile grasslands very quickly. We have a very good record of where this plant is on San Bruno Mountain because of surveys that have been done for the butterfly in particular. So since the silver spot calippe is listed, we were able to actually look at where Viola exists. And so here we go again with our dots. This is a similar map where we looked at Mission Blue earlier, and now we're looking at Viola. So the little yellow dots you'll notice are where the Viola locations had been, where Viola had been mapped. And again, what we're seeing here is a large reduction. We're getting an idea that although there are a lot of polygons that are mapped as grassland, this started to become an insight into what is high quality grassland that's being used by some of these species that we care about. So again, this is that proxy for how to determine not only where grasslands are, but where quality grasslands are. And so all this, the reason we put all this together, of course, is to come up with some suggestions and recommendations for managing San Bruno Mountain. San Bruno Mountain is wonderfully rich in biodiversity and wonderfully poor in management dollars. And that is no fault of the agencies and the people that are in charge now, but when this HCP was initially approved, the funding rates, the amount of management dollars were highly underestimated. And so we're really trying to figure out how do we do the best management we can, the most strategic management we can on these grasslands and retaining the few grasslands we have. So I got 3 lessons for you. Restoration lesson number 1 is if it's a grassland, keep it a grassland. It is very hard and expensive to create new grasslands out of areas that have been impacted by non-native scrub or have gone through a successionary process. There are a lot of elements you lose in the soil, in the seed bank, in pollinators and soil microbiota, all of that. So this is a study from Erecta Zavaleta and an associate of hers on how quickly an ecosystem changes once it's invaded by scrub. This study was actually done at Jasper Ridge, so it's extremely applicable. Jasper Ridge is about, 30 miles down the road from San Bruno Mountain. And what she noted is if you look at that green line is basically annual net primary productivity of herbs. So this is the herbaceous layer, the grassland layer, and years since invasion is how many years since coyote brush comes in. So in that, you can see it's here she's showing a very linear relationship between time of invasion and loss of resources. And so what this kind of research points us towards is saying, let's save the places that are great, that are least invaded first. Let's not spend all of our time on an area that's 50% invaded if we have other options to steward areas that are 5% invaded. So we came up with a metric for this report, and basically we have this graph that goes from green to black. Green is the highest priority, black is the lowest. I apologize if this font's a little bit small, but basically what we did is we took this photo, for instance, of one of these slopes and said, I wonder if we pull out half-acre areas or quarter-acre areas, where would they fit in this different management continuum? And our highest priority, as I mentioned in the previous slide, was grasslands that have 0% shrub cover and are coastal prairie and are occupied by listed species. So those are the areas where we wanted to focus our effort. And you might say, well, they're already good. Why are you going to spend any money there? again, as you saw on that previous graph, that deterioration in resources happens pretty quickly. So there's a huge effort and a worthwhile effort in getting out to these areas that are great and keeping them great. In our lowest priority, so in the other end of the graph, we find greater than 50% scrub and poor Calliope silver spot mission blue habitat. So that's that black square that says lowest priority in the top left. And basically what we're finding there is that's the last place we want to go. That's very expensive. Usually we're not getting the results we want to see, even if we are spending management and stewardship dollars there. So we're really focusing in on those areas where there's a little bit, just the beginnings of scrub invasion. So if you can see the numbers on this screen, area number 1, that would be an area we would want to continue to maintain, 2, 3, and then as you go, it goes down in priority with 4, you're starting to see more scrub. Rectangle 5, you're starting to see about 20% scrub, and rectangle 6, we're saying don't touch it. And that one also happens to be in a drainage, so there's a number of reasons why that's not an optimal spot. So taking that data, along with the Viola data and the Lupin data, we created this red, yellow, blue-green map, where the red is considered to be the absolute essential grassland. So we went ahead and looked at the 3,000 acres on San Bruno Mountain and said, these are the 431.2 acres we absolutely need a steward. And so we hope, and we've seen this with the agencies, they've been fairly receptive to this and said, okay, we now have a mandate, we now have a map, it has data behind it. These are the areas we need to continue to focus our management. If we happen to be extremely successful, win the lottery, whatever it may be, fall into a lot of management dollars, then we start to expand out into the valuable grassland, which are the yellows. And then the third we listed as potential. And so this is our effort at helping direct not only how stewardship should be done, but where it should be done spatially. You may notice that a lot of the red areas are connected. So there is, in this study, there is a component where we are thinking about how to continue to maintain critical corridors for these critters. Calliope silver spot flies a little better, so it would be more likely to use these corridors than, say, something like a mission blue, but we're trying hard to maintain that connectivity to all parts of the mountain. And here's a typical result. The picture on the left is pre-treatment. The picture on the right is post-treatment. It may not immediately strike you, but that means we're being successful. That means that we're following that mandate of let's knock out that baccharis, let's knock out that scrub that's just starting to invade in its very nascent stages. That's where we get the biggest bang for the buck. That's where we make the most, get the most pollinator habitat back, as well as butterfly habitat back in the shortest amount of time. Step number 2 is seed dispersal. Seed dispersal is becoming really limiting in California grasslands. There's a great study by Seambloom et al. From 2003. This was done at Hastings Reserve at UC. Again, not far from here, but what they found is over and over again, as biological invasions happened, there was a fairly definable pattern in which species started to fall out. One of those notably, Stu may talk about this, is the bay checker spot host plant, which is Plantago erecta. That is one of those annual forbs, which is native, which is absolutely gorgeous in its little own way. It is a very poor competitor, and it is one that falls out really quickly, and the seeds do not seem to be retained in that seed bank, and it doesn't disperse well. So One of the things we're trying to push, and we haven't talked about this too much on San Bruno Mountain in particular with the agencies, but it's this idea of we really need to start this local seed collection and dispersal program where we are thoughtfully collecting from plants that are local, that are native, that are vital for maintaining the diversity of the mountain, and then redistributing them in sites where there's been stewardship work. So as you imagine, you pull out some areas of Baccharis or coyote brush scrub, there's some bare ground, there's some disturbance. We would like to, we recommend actually engaging people, stewards, to go out there with proper permits and such to collect these seeds and redistribute them out to those areas. So that bottom right photo is Plantago erecta, Lupinus. When you think about these plants, you realize, they actually do not disperse very well. They drop seeds in the spot that they're at, and they don't move very well. Allium is another example. Its seeds do not move very well. So those are the plants we're recommending thinking about local seed collection and dispersal from. And then number 3, and I'm going to finish up here in 2 minutes, is heterogeneous disturbance maintains diversity. So this is an article by Stephen Warren. It's absolutely fantastic. It's only a couple pages long. But his idea here is that he used to work for the Department of Interior. I think he still does as a contractor. And what they found is per acre, the #1 land management with the highest density of endangered and threatened plants, listed plants, is the Department of Defense. Why? Because they tend to go in there, ravage certain landscapes, allow them to recover, meanwhile go ravage another landscape, allow it to recover, in some sort of a disturbance regime that was actually beneficial to a lot of these early successional plants that have been dropping out. So one of our study sites is the Serpentine Prairie. This is in Oakland. But what we're trying to do there is do mowing, grazing, spreading it out, different densities, different intensities, different timing from year to year to help create these disturbance patterns. So with the disturbance, you get variable germination. So temporally, things are germinating at different times, whether they're in bare ground or whether they're buried underneath litter. We're reducing soil, litter, and duff impacts, which can have dramatic impacts on nutrient cycling, soil temperatures, decomposition rates, wildlife use, and then, of course, native pollinators. We need to help maintain and create disturbance so that there can be bare areas for all of our native pollinators and ground nesters. So I'm almost near the end here, David, and I want to bring in the slogan, "Dare to go bare," and go ahead and it's okay to make some bare ground. You obviously don't want to make everything bare, but be thoughtful about that. And then finally, I have 2 slides left. Fire. Use fire as an opportunity. We're trying to do that, raise some money so that when it happens, you already have money in the bank. And so one thing we've been planning with the San Bruno Mountain Conservation folks is actually creating a fire fund where when a fire occurs, there's actually capital easily available to go in there and do stewardship and management after that. And that's what I have. Thank you.